Hello again, everyone. We've been discussing plotting lines from equations for a few videos now, including the fact that we only needed 2 points in order to plot the line. This time, we're going to start with 2 points and discuss how to write the equation of the line that passes through them. For this demonstration, let's find the equation of the line that passes through these 2 points, -1, -2, and 2, 10. To do this, we're going to need 2 important formulas. The first thing we're going to need to do is to find the slope of the line that passes through the 2 points. Recall that we interpreted the slope as rise over run. Put another way, this is the change in y over the change in x. And there's a slope formula that calculates just this. The formula tells us that the slope is equal to the change in y is y2 minus y1 over the change in x is x2 minus x1. Let's go over this notation. The x's and y's here are the x and y coordinates of our 2 points. We can call whichever point we want as our first and second, as long as we stay consistent in the first point being x1, y1, and the second point being x2, y2. Let's take a look at our 2 points here, and use this formula to calculate the slope. When you are first getting used to using this formula, it can be helpful to label which point you are calling first and second. I'm going to call the first point the -1, -2, which means my second point is the 2, 10. By assigning the first and second like this means the x-coordinate of my first point is x1, and the y-coordinate is y1. Meanwhile, the x-coordinate of my second point is x2, and the y-coordinate is y2. Now that I have appropriately labeled all of my coordinates, it's a simple matter to just plug into the slope formula. The slope is going to be equal to y2 is 10, then I'll subtract y1, let's be careful to leave any negatives inside parentheses, divided by x2 is 2, minus x1 is -1, leave that in parentheses again. Now since I was careful with my signs, I can see I'm subtracting negatives, which means this turns to 10 plus 2 over 2 plus 1, giving me 12 over 3. 12 divided by 3 gives me a slope of 4. So there is our slope for this line. Once we have the slope, how do we use it along with our points to create the equation of the line? This is where our second important formula comes in. There is an alternate form for our linear functions similar to the slope-intercept form we have discussed up to now. The form is referred to as point-slope form. And the form looks like this. Y minus y1 equals m the slope times parentheses x minus x1. The x and y without a subscript here will remain as x and y, while the x1 and y1 are the coordinates of a point on the line. These coordinates don't necessarily have to be the same as what we called the first point in our slope calculation, as long as it's a point on our line. Notice the slope goes into this formula, which is why we had to calculate it first. Using our 2 example points, which we just calculated the slope for, I can plug in the x and y coordinates from either point, but let's stick to what we called x1 and y1 before. We called -1, -2 our first point, so x1 is -1 and y1 is -2. Plugging in these values along with the slope will give us an equation that looks like this. Y minus y1 is -2 equals, the slope was 4, times x minus a -1. I'll go ahead and handle all the negatives appropriately, and we get something that looks like this. And this would be the equation of a line that passes through the 2 given points. We typically don't want to stop here, however, as we usually want to have our equation in slope-intercept form. To do this, we must simply solve for y. First, we'll distribute this 4 that's out in front of these parentheses. This will give us y plus 2 equals 4x plus 4. Then we want to get y by itself, so I'll subtract 2 from both sides, giving me y equals 4x plus 2 when I combine like terms. And so we end up with the equation of our line in slope-intercept form. We could go ahead and plug in the x values of -1 or 2 into this equation and check that we get the appropriate y values for the given 2 points. With that, we have covered most topics related to plotting lines and utilizing their linear functions. Until next time.